services with the different requirements at the same time by the same system. And when I say different requirements, for example, if we talk about IoT, the capacity might not be, capacity requirements might not be big, they actually might be quite low, but high tolerance also is not very significant, but the big amount of subscribers or offered devices actually leveraging is the requirements. Now, when we talk about mission critical applications, the capacity might be high for those, but latency perhaps may not or may be significant depending on the specific application. When we talk about mobile broadband, obviously capacity requirements are high, latency, medium requirements, and all the rest. Those are just an example. So the idea is that 5G runs all this over the same network at the same time. So network management is supposed to handle them. Now let's indeed look into 5G, and yesterday we spoke a little bit about it. Started from non-standalone, where basically 5G RAN is used with 4G core. Now, since last year, we start to see indeed many more 5G standalone implementations. Last year we have 8. This year already we have 20. Now let's face it, it is less than we actually thought will be by now, but the train is moving. And these are good news. So the expectation is that this year, perhaps at the beginning of next year, we will see more and more 5G standalone networks. And then probably not yet on scale, not yet supporting many slicing on many different services, as I showed before at the same time, but started to move. And then starting later, we will see what we call 5G at scale, where really, slicing is implemented for many services simultaneously, and actually, we have a wide 5G SA deployments in many networks. Now, what is the challenge there? So, there are several things not directly related to 5G standards, but really closely associated with 5G. And when you say 5G, you basically mean those things. So one of them is network cloudification. So network cloudification, existence of edge, existence of core. Now, edge standardization started long before 5G, but actually the mass edge deployment we will see inside of 5G deployment, and this is the reality. The hybrid cloud also, public and private cloud provided by the service providers, along with the hyperscalers, a wide support of hyperscalers, actually the capability to get and choose between public and private cloud and to get to deploy network functions and to select and deploy network function on each of them is also part of 5G capability. Now, of course, service-based architecture, that is actually one which is part of 5G standardization. And network slicing, again, the first time that architecture is built in the way which allows to run multiple services over different slices, each one of the slice corresponding to the requirement of that service over the same network. Monetization is a very important one because obviously service providers, technology is a nice thing. Without having a monetization or a new monetization strategy, there will be challenging to convince someone to deploy a new network. Now, 5G does bring a new monetization strategy, and I will talk a little bit about this in the next slides. And of course, RAN transformation. Getting to ORAN, getting to the first implementation of ORAN, perhaps not yet with implementation of RIG, but still, splitting CUD, URU, implementing standardized interfaces between them. All those are parts of 5G, either fundamentally part of 5G standardization or those technologies which are associated with 5G. For some reason, I cannot move to the next slide. Okay, now I think I missed, yes. So we can see, by the previous one, we can see actually that the complexity of the network is becoming much higher because obviously, when you have disaggregated network, when you have deployment edge at the different types of the cloud, the complexity of network operation complexity is becoming much higher. And network becoming is much more complex in order, and really there is a need to close that gap between the complexity and the previous implementations of the network management system. Now, in order to resolve that, of course, there are several separate parts of the network management system. One of them is business-driven service design, which actually capturing the business intent of the specific services. The second piece is the orchestration, end-to-end, and also domain orchestration, service network orchestration, and also inside of the network domain, RAN, core, and transport orchestration, which actually translate business intent into action. Now, inventory, real-time federated inventory, which provides comprehensive view of the hybrid network, including PNFs, CNF, VNFs, actually including those cloud deployments on public and private cloud and showing everything at the same time. And of course, AI/ML-driven closed-loop assurance, which actually automatically adapts service impacts in the network in order to not have a human intervention and to be able to to apply automation in the closed loop by actually monitor the network and apply closed loop action in order for network to stand against the requirements for specific service. Now, a few words about each one of them. This basically shows graphically how this whole thing works. But service network design basically is design time entity, which brings the model, which creates and brings the model, and then the orchestration system consisting of orchestration, inventory, and assurance get the business intent. It applies those models and applies an action in order to stand against those models. Of course, it works in the closed loop, as I said, by getting the feedback from the network of MPM measurements and so on, and enhancing, addressing the changes in the network in order to stand against capacity, latency, and so on requirements, so service gets the required bandwidth, the required latency, and so on. Now, a few words about each one of them. So basically, design is a single catalog for service and resource design, support service modeling, very important, support the different types of the network functions, VNF, CNF, cloud native, supports slicing design modeling, now supports a distributed model for RAN, MAC, core, transport across all of them, and of course creates a policy, intent definition for orchestration and assurance. Now, when we talk about orchestration, again, the challenge here is to connect in mobile different domains, RAN, core, transport, and provide an orchestration on each one of those domains, but also orchestration end-to-end, which communicates with those domains. And basically, in 3GPP terminology, it is CSMF, NSMF, and then NSSMFs per different domains. All this needs to be supported by the orchestration system, and there might be several orchestrations, such an orchestration system. So the challenge is to be able to build that as a whole one, but also be able to integrate with the vendor, with the different vendors' orchestration system per the different domain if that is required. Of course, supporting PNF, CNF, VNF, supporting different clouds, policy enforcement, homing and placement, the capability to select network functions on specific cloud, again, selected between private and public per different requirements. One word I wanted to add here about monetization, as I briefly mentioned that before. 5G is the first standards which actually allows charging to be not just by mobile subscriber session, but actually by slicing. So it's provide, and in such an approach, orchestration becomes a charge and trigger function. So it reports not of subscriber level, but it actually reports on a slice events level, slice creation, slice instantiation, slice termination, slice capacity, the quality of service for services running over that slice. And that is really innovative. So that can really give a new monetization strategy, a new monetization model for service providers who want to deploy slicing and seeking how they monetize that and become it profitable. So that's really the tool which provides them with that. So this is why, slicing is not just about network management. Slicing is also about network monetization. And for me, this is one of the key characteristics of the slicing. Now, inventory, of course, comprehensive view of services, slices, all the network functions, private, public cloud, different types of the cloud, end-to-end visibility, and also the ability to connect to a different inventories. For example, again, if there are more inventories in each of the domains, the inventory should be able to connect with those inventory and get an information from there and present a comprehensive view of all of the resources, of all of the network functions, of all of the services and slices in the network. Now, assurance. So, we all know about assurance, about collecting measurements, FM, PM, configuration management, tracing, logging, basically measuring against the KPI and correcting the action in the closed loop, of course, intent-based, along with the orchestration. So basically, user does not have to intervene, and all this correction and standing against the requirements will be done in the closed loop. Now, assurance perhaps right now is the most challenging and most interesting part of what is being discussed in 5G, because for assurance, there is an NWDAF, which is a part of 5G core. There is an MDAF recently and now in process of developing by 3GPP SA5, which is more close to this definition, which is really about network management analytics. There is also non-real-time RIC and near real-time RIC in ORAN, which are also largely about assurance. So the challenge here is to be able to define which use cases belong to NWDAF, which use cases belong to MDAF, which use cases belong to ORAN. Not simple at all, because there is a significant overlap of the standards on this, and we as a vendor, just to jump in a little bit into that, we support all of them, but for us, again, we define which of the use cases belong to MDAF, which of the use cases belong to the NWDAF, which of the use cases belong to RIC, and then we support them appropriately. Now, after all those 2 days, perhaps no need to describe what intent is, but, just in a few words, basically, intent for us to be on the same page. Intent is there you want to get, so basically KPIs of the service without actually explaining and defining all those algorithms. If that happens, you do what? If this happens, you do this. So basically allows, and I am going to simplify it a little bit, but it allows the service providers to not get into definition of all those very complicated multiple workflows, what happens in each situation, but actually define what is the deserved outcome. So vendor has that hard work to do to actually define those algorithms, how, we would be getting there. This is something, which actually shows perhaps to the service provider the advantages of implementing intent-driven orchestration, where basically the complexity is moving from the service providers of defining all the possible scenario to the vendor, when service provider just defines, where he wants to get. And, these are just some of the example of what I said. So, in orchestration, you basically define the end state and how you get there without really explaining the detailed workflow. In assurance, you define the KPIs which service have to stand against. And then, you are getting there without really defining thousands of events with different resolution rules and, what you would do without intent-based. So to me, intent-based really, without intent-based, let's put it this way, without intent-based, it would be extremely difficult to impossible to really leverage the capability that 5G brings, because if you talk about slicing and if you talk about multiple slicing, for each of the slices, for each of the service, you would have to define so many workflows and so many conditions and so many situations in which you would have to do certain things that perhaps you would think twice whether you need to implement it or not. With the implementation of intent-driven, it becomes much easier. So for me, the success of actually deploying 5G network management with slicing and leverage all what 5G gives, becoming an intent-based or bringing the intent-based management system is a must. That basically shows, again, that system containing of design time and runtime, basically design time on providing the models, and then in runtime, which gets business intent, there is a closed loop between deciding based on business intent requirements, for example, latency, bandwidth requirements, and so on. Then do the action to meet business intent, for example, select edge cloud or select cloud by the certain cloud providers. Then detect, again, get to the measurements and get all the measurements and understand basically whether they stand against those KPIs defined in the network. Diagnose, finally, identify impact and cause latency, basically identify what needs to be changed in the service in order for service to stand against the requirements if there are problems, and implement it in decide, and this way goes in the closed loop. Now, intent-driven placement and homing is extremely important feature. And, in short, it is indeed the capability of actually being able to decide whether, for some certain service, when you define slice, to place network function on edge cloud, on private cloud of the service provider, on public cloud, it is not just, by one parameter, it is basically an algorithm consisting of the multiple parameters. It includes service provider preferences, of course, because the cost might be significantly different between deploying network function on different clouds. Very important, standing against service requirements, because, for example, for something which is location sensitive or low latency sensitive, you do need to put it close to the user to place network functions close to the user. Affinity, non-affinity rules, all different security requirements, all those different parameters basically that you put into your algorithm, and with the different weights, and weights, by the way, in our view, may also be provided by the service provider eventually, like, for one service provider might be, standing strictly against the service requirements, the most important thing. For the other one, cost is the most important thing, and so on. And then eventually coming to the decision where to deploy the network functions, how to deploy slicing, physically, where those network functions deployed is extremely important thing, and in the network management system of tomorrow. And finally, to finish that with that, of course, we in Amdocs supporting that network management system. It is called INS, Intelligent Network Suite, where basically we support those 4 components: service design, orchestration, inventory, and assurance. Where service design is business-driven, onboarding for hybrid network, which basically, again, supports PNFs, VNFs, CNFs, all those types of the network functions, model-driven execution for runtime components. It works by standards, standardized distribution, integration of service definition. Basically, most of that is defined by ETSI-NFV. Then orchestration system, of course, network function placement and homing is supported. 5G slice, edge automation, as I've described, extremely important for that. Orchestration among different domains, RAN, core, transport, different vendors and different types of the cloud, also supporting slicing charging by the orchestration. Then inventory, real-time view of hybrid services, edge data center resources, and basically all of the resources and all of the services and slices in the network. And assurance, again, supporting services in the closed loop, supporting the different layers of assurance, MDAF and WDAF, RIG, implementing of use cases where it belongs, actually, those use cases belong to the network management largely implemented by pre-GPP compliant MDAF, which is now in process of standardization, which we are following and implementing once it is being defined by standard, based on the IML. That's largely the system that we support, and we have a booth also here. We would be happy to discuss with you in more details the system which we have. I guess the important thing that I wanted to highlight at the end of my presentation, that that the network technology is changing, and unless we use that network management system which actually support all those things, we would not be able to actually use 5G as we should. And if that becomes just yet another definition of G, like similar to 4G, like using one same network with a very simple network management run by different vendors, we would not get to the benefits of 5G. We would not be able to monetize 5G. Thank you very much.